Okay. I realized that what I discussed about tuples in the previous video was erroneously removed by the video editor. So especially at the end of it, so I have to redo it again, especially from the starting with tuples, and then we can continue with other concepts. So tuple, like list, is another data structure that is used by Python, which are closely related anyway. The only difference is, or the major difference is that tuples cannot be modified, unlike the list. With the list, you can play around and add or remove some of the elements, but with tuples you cannot do that. So as a result, it has only two methods: counting, certain numbers. For example, how many, let's say you have a list of numbers, let's say 1, 2, 3, 4, 2, 2, 2, and then how many twos are in that list, in that tuple. So you can use the count method, or you can use the index to get an index of a certain number. So let me give you an example as I speak. So let's look at a list or a tuple of numbers. Now the difference between tuple, again, another difference between tuple and list is that with list you use the square brackets, but with tuples you use this as a parenthesis or these other brackets. So let's say you have a number list, let's say 4, 3, 2, 2, and 5 and 4 perhaps. This is a tuple of numbers, right? So we can count occurrence of a certain number. Let's say 2. Oh, sorry, 2. So how do we do that? We can use a count method by saying numbers dot count. And what are we counting? We're counting number 2. So we can print this to the screen by saying, sorry, this is supposed to be print numbers like that, right? So what do we get when we print? We're getting, there are 3 2s here. You can see this is the first number, the second, third, right? So you can change also to something else. Let's say 4. How many 4s? I guess you can get there 2. So if we run, we're expecting to get 2. And how many 3s are in there? I think it's 1. So you can get 1. So you can play around and see how much you get. Okay. So that's the first method, counting occurrence or the frequency of a certain number. And also you can see the index of a particular number. You can get index of a certain number. Let's say number 4. Let me put EG number 4. How do we get the index? We also say numbers dot index of that particular number. Let's say 4, right? You can also print this into screen by saying print that one, and then we can get 2. So index of 4, which is this one. So this is 0, this is 1, this is 2. So we're getting the index of the first 4. Remember there are 2 4s here. So the first 4 is what is at index 2, right? So that's the concept of tuples. You can extend your example to another example. Let's say you have fruits which are in a list, sorry, in a tuple, and our fruit, the first one could be anything. Let's say apple, right? And probably we have a banana, and okay, let's say you have blueberry or blackberry, whatever, blueberry, right? Now with this tuple, you may want to print what are the, because we have only 2 methods, but you can use the print as well to say, okay, want to get the fluids, the list will be printed just like a list, just like a tuple, the way it is, right? So, but you may also want to look through this list. You may want to look through. What do we get? So we can say for an item or for item in fluids, right? What do we want to do? We want to print that item, right? Instead of listing in this way, you can do it in an intelligent way, right? So what do we get? Oh, sorry, my 4 is crazy. It's supposed to be 4. So the running, you can see there is apple, banana, and blueberry. I hope you can see that. So you can look through a tuple just the same way you would have done it using. I mean, you would have done it in lists. So tuples and lists, remember, are closely related, but the difference is that these ones cannot be, the elements in it can't be changed. They are immutable. And so you cannot pop, you cannot, you cannot delete, you cannot add anything. And so it becomes limited with the number of functions that it can support. All right, thank you. So the other concept is unpacking. Now you have a list, a tuple like this. I remember this unpacking thing is for tuples. You can unpack it, and let's suppose you have some, let me call it coordinates, which are in a tuple. Coordinates like, coordinates you normally use these brackets, these parentheses, right? So you can unpack this into individual. Let's say this is the first, the X coordinate, and this is the Y coordinate, and this is the Z coordinate. So you can say, well, the first thing should be X coordinate. So you can assign that to coordinate. How do I write it? Coordinate. Coordinate at 0 index. So that is the X, and the Y should be coordinate at Y, sorry, at the first index, and then Z should be coordinate at second index. I'm messing up, right? So, and then you can do whatever manipulation with that. But this other way you have assigned those coordinates to individual variables, right? So you can play around with, some multiplications perhaps. You want to multiply those coordinates, right? And once you run that, you can see it is 6. But anyway, this is a little bit messy. You have to repeat a lot. There's a cleaner way to do it. And the cleaner way to do is using unpacking. Now that one was like repeating everything. You don't really unpack. And how do you unpack? You can say unpack. How do you unpack? You could say, instead of X is equal to coordinate at 0, you could just say X, Y, Z equals to coordinates. Right? That's the simplest way. And you can do your printing. You can say, well, I want to print using X times Y times Z. Now, in order for you not to be confused with this, let me just comment it out. Let me comment out this as well. Comment out this as well, and comment out this as well, right? And see, we are getting almost the same, not almost, we are getting the same with that 6, right? So that's the way you can do unpacking. You can even select, well, I just want to print, let me say Y. What is the value of Y? You see, Y is 2. So this is the easiest way. Instead of writing all this, you could simply just write this in a cleaner way called unpacking. Let me uncomment this for record keeping, but the best way is to use unpacking. And that's the concept of unpacking. Right, another concept is dictionary. This is just like what we have discussed about, strings, integers, tuples, lists, it is also a data type in Python. And I think it's unique to Python. You don't find dictionaries in other languages. If I'm wrong, of course, you can correct me. I'm not an expert in this, in all those languages. But dictionaries is a popular data type or data structure in Python. And how do they look like? Dictionaries normally have, how do you call it? An item value kind of a pair, right? So for example, you have a person, right? A person normally may be associated with, their names, their age. So a name can be an item, and then let's say Joseph is a value for that name, right? So you have those kind of pairs. Age, and age must have a value, let's say 24 years, right? You see, those kind of things. Now, Python has this wonderful data type or data structure which accommodates such thing. Now, let's assume we have a customer, right? Now, a customer has all those values. Now, with dictionaries, instead of using square bracket like for lists or parentheses like for tuples, we use these curled brackets, right? Now you can just put it this way and say this is the item name, right? And what is the value? Well, I suppose this is Joseph. I put my name in here, right? And let's assume the age. Now remember, everything here is in quotes. You can use double quotes or single quotes. The item itself and the value, they're all, I'm not sure. Let me just put in any number, right? Let me use 24. That's not my age anyway. But, and again, one more thing is remember to separate it using comma. You remember to separate those items or those items in a dictionary using comma. And probably we have another item, probably is verified. I'm just coming up with some variables. Verified. And probably the answer is, I don't know. I'm messing up. I'm supposed to use not equal sign. Yeah, this is the biggest mistake. I'm not supposed to use equal sign. I'm supposed to use this full column. Sorry about that. So is he verified? I don't know. We are talking about verified customers. Now, is he verified? Probably we just want to take a Boolean value, right? Let's say true, right? Now, that's the end of my dictionary. You can have a dictionary with a lot of other information. Remember to have each item must have a value, right? Must have a value. And the value, I mean, the items should be unique. You can't have name and then name in one dictionary. That will, Python will complain about such practice. So let me start with the simplest thing, to print this customer, right? What do I get if I run? I'm getting everything that's bundled, just like the way we did for lists, just the way we did for tuples. Once you print that whole thing or that whole variable that's scaling everything, you get presented with everything on the screen. Just like here, name is Joseph, and then age is this much, and then verified, probably it is true, right? So that's one approach. You can even get the length. What is the length of this? Now, length, we have seen a length as a method somewhere. You can also get a length of a dictionary. What do you get? Length is counted as these items. Like this is the first item with its respective value, the second, the third. So if we say we want to get the length, use the length of a customer. I want to print this. So let me say print length of a customer. How much do we get? If we run, yes, that's 3. So this is the first, the second, the third item with its respective value. Okay. Yeah. But suppose we don't wanna print everything. We don't want to print the customer with everything. We don't want to print the customer with an age, with the is verified. We just want to get the name, for instance. So you could even go straight or specific to getting the name by saying you want to just access the name. So you can say customer, and then you put into square brackets, something like this. And then you say, well, we just want to access the name, right? I want to print this to the screen. So what if I print it? What do I get? I'm getting Joseph Telemar. If I change this to age, you can see something different. You see 24. I hope you're together. So let me get back to my name. Okay. So that's one way. The other way to get a particular item with its, a particular value, you may not use this customer then bracket. You can use the get method. You can also use get. Let me put it this way: dot get, and then instead of using those square brackets, you can use these parentheses, and then you can specify the value that you want to get. Are we together? The item that you want to get. So for instance, you want to get the name. So how do I write it? You can say customer dot get. What do you want to get? Yeah, I want to get the name, right? So this actually does the same thing as this one, at this here, right? So let me just print it to the screen, and then and if I run it, you can see I'm getting two Joseph Telemaras. Why? Because this is also doing the same thing as this one. So you can use get instead of using customer, then black square bracket, and then you specify the item that you want to access. Now get has several advantages. One advantage of using the get method is dealing with missing values. For instance, someone wants to access a key or an item. Well, the other name for item is a key. Okay, so someone suppose what if we want to access a key or an item? We've been using item. We're not using it this way. A key or item that does not exist, right? So, for instance, we wanna say customer, then we specify the value. Let's say date. I'm using this way. Birth date. Birth date. Birth date is not in here. We just have an age, not birth date. What if we print this? What do we get? Right? What do we get whenever we print this? Let me use print, and then we can specify like that one. You see it's giving us an error. Okay. And the error is comparing that. Sorry, what is the error? What does it say? Key error is birth date, right? The key that we are trying to specify, or the item that we're trying to specify, actually does not exist. Also, alternatively, you don't use this one. Let me comment it out and use get. So you could say customer dot get. What do we get? Birth date, right? Let me print this and say print. Okay. If we print this, let me run and see if we are getting an error. We are not getting an error, we are getting none. So this is a cleaner way to deal with missing keys or missing items. If someone erroneously specifies that a key that does not exist, if you use get, it's more, safer way to get through the program instead of running into an error, right? But also with the get, you can even specify some default values. So with the get, method, you can specify some default values for the keys that do not exist. What I mean is, using our base date, you can say customer.get, and then you specify base date, date. If the value doesn't exist, you can say, well, I just want to put a default year. Let's say 1970. Let me just use January 1st, 1970, right? Someone doesn't specify the best date, you can just assign them to such. Instead of saying none, it would now change this, change something like this, which is none, into something different. Let me print this. Let me say print, and let's see what we can get. Yes, that's January 1st, 1970. So instead of using this plain approach, you could use the get. Instead of using this plain, you use the get, and then you can even specify some default values wherever a key is missing in your dictionary. All right. You can also update some values in a given key. For instance, you can also update some values of a given key or item. For instance, we have customer name, which we want to change it to someone else. It was Joseph. Now we want to get someone else, let's say YEESI Micro, right? If we print the customer now using this function here, the customer name, something should be now different because we have changed it. So let's try and see what we get. You can see YEESI Micro at the end. It was different because until this point, the name was Joseph. But whenever the program was running, remember I said in one of my videos that Python executes sequentially. So it was going through sequence, and then when it got to this point, we saw that the name has been changed to YEESI Micro, and now it is YEESI Micro, and things like that. So I hope we are all together and everything is fine. All right, so let's see the concept of functions. For most of you, I believe you have come across functions. I've been mentioning functions all along. I gave you some examples of mathematical functions. You know, you can use them which are already implemented by others. But in what I call modular programming, someone can come up with their functions and then put them together in one bigger module. We saw some of the examples which were math functions and NumPy function, NumPy module. Let me not call them functions, because within a module there's a lot of functions. For math, for instance, for a math module, there were a lot of functions like rounding of absolute values, pi. All those things are actually functions. In NumPy as well, you can have a lot of functions like array and several others. So let's see how you can define a function. As you go along, it is obviously expected that you may have to define some functions for you. Now, I will just give you some simple functions, right? And let me just define a simple function. Now, in Python, we use def, which means define. It's unlike Java, which has a lot of complications like public, static, void, blah blah blah, class, and all. Now here we don't need all those things. We just need to write this keyword def, which means define. Let me just print a simple message about welcoming something. Now, you want to write this simple method function to welcome someone. We just print a simple message like hi there. Okay, and let me just print another line, welcoming someone to our course. Welcome to YEESI 100. All right, so probably this is the end of my function. Now, Python is a little bit crazy in some way because it may require you to, jump like 2 lines before calling that function. So how do you call a function? Just say welcome, and that's it. Just remember to put those brackets to mean that you're calling the function called welcome. If I run this, I expect this content here to be displayed. Let me try to run it. Hi there, welcome to YEESI 100. So that's it. Someone may add also some other, crazy stuff. Like, let me just say, I want to start the function. Or just put anything, it doesn't matter, right? And probably after calling that function, I want to print another message and say end, right? If I run it, you see the content of my function is in between the start and the end or the finish. Okay, so that's one way. The other way is a function. This function had no parameters, right? It had no parameters. Now I wanna add some parameters. Let me create parameters. I think parameters. Now let me change this to something was wrong here. Let me change it to right. Let me create a parameter. Now let me just copy my message here. A little bit my function anyway, and say instead of just leaving it blank here, I want to specify the name of that particular person. Now instead of there, I just say name. I supply that variable, but now let me not do that. Let me use this formatted string, if you can remember it, and say hi somebody. Let me specify it like this and say name, right? You can remember this thing. Welcome to YEESI 100. And then remember, when you're calling it, remember to specify that name, because it is expecting to get a name. Now, a name here is supplied as an argument. So you could say my argument is now John, right? So let me run it. You can see that it is saying, okay, start, hi John, welcome to YEESI 100, right? We supply this as an argument. So let me just say, John is an argument. Okay, so anyway, in this part here, we'll talk about the difference between the two, but I think you can guess what an argument is and what. Let me just say it straightforward. Like you should note the difference between the parameter and the argument. For this case, note the difference. Let me put it this way. Note the difference. Welcome. Bracket name, which is this one here. We put these symbols. Name here means a parameter. Let me comment them out. And when we say welcome, by specifying the particular value of that name, like John, John here means an argument or an argument, right? All right. So that's the concept of parameters and argument. But again, there's another concept called keyword argument. Now, before we look at the keyword argument, there's something called positional argument. So let me add that word here. Positional versus keyword argument. Okay. Now let's get back to our example. Let me take this example and put it here. Let me remove this. I think let me remove these other things. I think I don't need them. I just put them for demonstration. I don't know if that's not my purpose. Now let's say we have two names, right? We can have the first name, and our function is taking two parameters, right? And the last name, I mean L name, right? So in here we say hi, first name or F name, space, last name. Okay, and when we are calling here, we can say John, comma, Michael. I don't know why I like the name John Michael. Just the name. Okay. So if we run this, we are talking about position argument. I will tell you why. If you run this, you can see, hi, John Michael, welcome to blah, blah, blah. Okay. Now, let me suppose Michael is a surname or is the last name. Let me put it at the beginning. What will be the outcome? If you take this to the beginning, who can guess what will be the output? We know for sure Michael is the surname and John is the first name, right? And we are expecting that the first name should start, right? If that's the case, if we run, you can see, hi, Michael John. Now this is messing up because it is starting with the surname instead of the first name. So that is what we call positional argument. Positional argument in this sense means the position should be kept the way it is defined in here. If you change the positions in the argument part, I mean in the argument part, sorry, if you change the position to differ from the parameters into the argument part, then you're in trouble. That's you're messing up with the structure. Okay, so you should be careful. Okay, and so you need to be very careful when you're saying first name, and then you should be doing the same in whenever you're trying to give those arguments. Now, somehow it may be important to say, well, why don't I just define that this is the first name? What I mean is, let me say, wow, this is the last name, L name. And then there is John. What will be the output? We need to assume that, okay, because you have said L name is Michael, then John should be the first name. What will be the output? If we run that, it is complaining. Positional argument follows keyword argument. So now there comes the idea of keyword argument, right? So it is messing up. Let me not do it. Let me run again and see what comes. Well, in other words, what they mean is, let me comment out this and say, welcome, John, comma, L name, to mean Michael. Whenever you're saying this way, you starting with a positional, and then this is a keyword. With a keyword, you specify explicitly what an argument is. But anyway, let me give you another example. This is not quite suitable. Let me assume there's a function called calculate cost, and within calculating cost, we have a total, let's say 500, right? This is the number, so we don't need to put it in the quotes. And we have shipping cost, maybe 45, and we have, let's say, a discount of 0.2, right? So it is not clear what these things are. This is what I mean. It is not clear what these numbers mean or means, right? Unless someone goes through your code and say you have defined them somewhere. I haven't defined the function cost, calculate cost, but I assume it is defined somewhere. I'm just putting in the arguments. But 500, 45. So this is quite not clear. But whenever you see the names, you may guess, well, this is the first name, this is the last name, but you can't guess what this is. And so there comes the idea of keyword argument. So you could write it alternatively, you could write it differently by saying calc cost and say, well, the first one is total, which is 500, and the second one is shipping cost, which is 45, and the last one is discount, which is 20%, 0.2, right? This is more clear. It makes the code more readable. It makes the code more readable. So you can enhance readability of your code by defining the keyword argument. So instead of just throwing in the values, you could just specify. So let me put a note down here so you can remember to distinguish between the positional, or where to use the positional argument versus where to use the keyword argument. For the most part, use positional arguments. It's not quite necessary to specify it this way. It makes your code like, redundant. For instance, if you have defined this parameter somewhere, you don't need to repeat them unless it is very necessary. And when is it very necessary? So for the most part, use positional arguments, unless you are dealing with numerical values. Unless you are dealing with numerical values. Like here, whenever you're dealing with numerical values, it's quite important to use keyword arguments. Otherwise, no. Now, if you are using positional and keyword arguments in a function, start with the positional argument. So if you are using positional and keyword arguments in a single function or in a function, remember to start with positional argument. Remember, I wrote it somewhere here and it complained. Whenever you start with keyword argument like L name at the beginning and then followed by positional, it will complain. So remember to follow that that kind of a standard. But again, use keyword argument to improve readability. Keyword argument to improve readability of your code. Whenever a function, kills, or a function K-result takes values that maybe or that could be or that may be difficult to understand. Okay. So it is important to you to differentiate between the two. Okay. All right. I hope you're together and everything is clear. As we have seen so far, Python looks quite natural. You see, a lot of things are just like, you know, you're talking or you're doing some natural activity like speaking English, and a lot of them are just like that. So whenever you're applying Python in whatever application you're using, you're developing, you see it's not difficult. Okay. Another thing before closing up today's session is dealing with functions that returns something to the user. For example, you have a function that calculates. Need to change this function that calculates some variables or some values, and you want the results to be returned to the user. So let me define a function for calculating square root. We just call it square root of a number n, right? And we want to just return, actually it is just n by n, that's the square root of n, right? So it's n times n. So you want to return that thing. So you could just write it this way, return n times n. Someone would have written it this way. That's my point. But what will you do with this? You wanna get whatever is calculated and then give it to the user. You don't really do that with these other functions, but whenever you're dealing with some mathematical functions that calculate some values, then remember to add the keyword return. And then whenever you're calling it, you're calling your function, let's say of the number 4, then it calculates easily. So let me run and see what comes out. The square of 4 is 16. You can use it this way. You can add the word print. I think it doesn't matter. So as you can see, I've just said square of that number, and then I'm getting the result. So it's 16. Okay. Let me stop at this point, and then we can continue in another tutorial looking at the idea of exceptions and several other concepts. Thank you, and enjoy your time.